Today we're looking at assignment number 9, rectangular coordinates and graphing. Now in this course we make the assumption that you've seen the rectangular coordinate system, the XY grid. So let's just make sure you know what I'm talking about. We can divide a flat surface, a plane, into 4 distinct regions through the use of 2 number lines. We have a vertical number line and a horizontal number line. The horizontal number line is called the x-axis, and the vertical number line is referred to as the y-axis.
Talk loud. The speaker's going out, hasn't it?
Yes, it has. Okay, can y'all hear me? Over there in the peanut gallery, y'all can hear me? Yes? Okay. And the point of intersection of these 2 number lines corresponds to 0. So that point right there in the middle, that's the number 0 on both number lines. So if you have 0 there, to the right it's a number line. So to the right is positive. To the left is negative. And on the vertical number line, up is positive and down is negative. And we can refer to any spot on this plane through the use of something called an ordered pair. It's an ordered pair of numbers. It's a pair of numbers, and the order in which you write them is important. For example, the ordered pair 2, 1 would be located right where I put that red dot. You always start here at the point of intersection for measuring. That's referred to as the origin, this point of intersection. You'd have to go 2 units to the right to get positioned right underneath that dot, and then you'd go up 1 unit, hence the ordered pair 2, 1. Compare that to the ordered pair 1, 2. With 1, 2, you'd start at the origin, you'd go 1 unit to the right, and 2 units up. Is this familiar to you? Yes? Okay, if it's really familiar to you, then you can give me some points. What about this thing right there? What would be the ordered pair representation of this point right there?
Negative 1, 3. Negative 3.
Oh, okay, negative 3. The x value would be negative 3. And then the right value, the y value would be positive 1. What about right here?
Negative 2, negative 3.
So we go left 2 and down 3, left 2 and down 3, and here?
4, negative 2.
Okay.
X is always first.
Okay, x is always first. Because of the order does matter. I have an idea. I said that we could identify any spot on this plane through the use of ordered pairs. What about that one right here on the y-axis? What would be the ordered pair representation of that point that I'm pointing at right now? Okay, left, right, you'd move 0. And then, so the x-coordinate is 0. The y-coordinate is what?
4.
4, okay. And let's do another one right here.
0, negative 2.
Okay. If the point is on the y-axis, for it to be on the y-axis, you can't move left, right. So the x value will always be 0. The y value in that case is negative 2. Any questions on our logic there? So I'm going to make a note of something. If a point is on the y-axis, its x value will always be what number? 0. If a point is on the y-axis, the x value is 0. What about a point on the x-axis? Let's look at this one right there.
4, 0.
Okay, you have to move 4 units to the right, so the x value is a positive 4, but you can't go up or down. If you're going to stay on the x-axis, the y value must be what? 0. And one more, just to make sure you got it.
Beat that dead horse, Tim.
Oh, thank you. Okay. We go left 2, and so the x value is negative 2. The y value is 0. So what can we conclude about all the y values on the x-axis? We said that on the y-axis, the x values are 0. Okay, so if a point is on the x-axis, the y value is equal to 0.
Hopefully we won't get any questions where it's like, oh, it's actually like 1 millimeter above the x-axis.
Well,
so
that could happen. I'm only using the points that are easy to identify with integer coordinates, okay? But we could have 1.5, comma, 4.5. So that could happen, but for the illustrational purposes, I'm hoping that, and I think the ones on the assignment, almost all of them, if not all of them, certainly the vast majority of the ordered pairs you'll be generating will be integer values. So MyLab makes that nice for us.
Yeah,
We're
you know there's going to eventually be like one question there down where it's like, oh, it's actually like 0.1 millimeter above the x-axis, so putting 0 for it was wrong.
Oh,
Yeah.
they're not that harsh on it. There's actually some nice graphing tools that we're going to use. And, I think it'd be very hard on those for you to graph just like 0.1 or something, okay? Everything's at integer units.
We're going to be graphing today lines, quadratics, conics, square root expressions, and absolute values. So 5 different figures today. So the first one we're going to be graphing will be a line. The equation of a line doesn't have any exponents. If it's a line, the equation, you should be able to write the equation in the form. Oh, switch it over.
I was going to pull up the question, but okay, you go ahead and write.
First of all, a line, you should be able to write in the form ax plus by is equal to some constant c.
You might not want to write it like that. It might be written in another form, but there should be no exponents on the x and y.
That's what I was about to say. Notice you just have x's or y's. Technically, you could only have one of them. You might only have one of them. If the coefficient of x is 0, you'd only have a y. Likewise, if the coefficient of y were 0, you'd only have the x variable. But you can't have x squares, you can't have square roots, or absolute values appearing if the graph represents a line. How many points do we need to draw a line? How many ordered pairs? If you're going to draw a line, what's the minimum number of points you need? 2 points, okay? We'll use 2 points. I know that in high school you may have been told, oh, use 3 just to be safe. But MyLab, if it's a line, they're going to want you to find 2 points and draw the graph. 2 points uniquely determine a line. So you only need 2 points. And there's a very nice graphing tool for drawing lines. So let's look at number 1 from the assignment.
You'll notice we're letting you just skip. You can start the assignment without doing the videos, but if you want 100, you've got to click on these and get, there. You don't even have to let it, okay, as long as you get the green check, okay? But I'm not just trying to make 100 here, so I'll just skip on over to problem number 1.
At least a 70 move on.
Yes.
Mm-hmm. So it says to give ordered pairs that are solutions to the equation and then graph the equation. We have the equation is 3y is equal to 4x minus 12.
table.
Oh, wait a minute. I didn't see the table.
Oh, well, I mean, it's just that.
Okay, so they've given us a table.
When x is 0, what is y?
Exactly. So you plug it in 0 for x and calculate y.
Switch.
Okay?
So
Okay.
x for y equals -4.
Look at this table of values. They give you that number there under the x column. That's saying let x be 0. They want you to find the value of y. So we're coming over here using this equation. We're plugging in 0 for x. So we have 3y is equal to 4 times 0 is just
0.
0 minus 12. That says 3y is equal to -12.
Divide by 3 on both sides, so it equals y equals -4.
So there's our y value of -4. So we go back over here and we type in -4. Okay. Oh, look at that. They've given us another row on this table. What is this new row saying?
Y, if y equals 0, what?
Okay, they have a 0 for y. They want us to find x. So here we are. I go back to the equation. I'm going to replace y with 0. Can y'all see that? Yeah, okay. Y equals 0.
So it's 3 times 0.
Which is?
0. So 0 equals 4x minus 12.
And we know what we have to do to solve for x now. I would get rid of that minus 12.
Plus 12 on both sides.
Okay, so that would give us a positive 12 equals 4x, and then
Divide by 4 on both sides, so x equals 3.
I agree. Any questions there? All we need are 2 points to draw a line.
I always like to put the parentheses around the ordered pair, even though they don't.
And
Just for illustration.
I don't, but I mean, it's a fine thing to do. So we come over here. Let me type in the 3. Tony has caught on me with all of this stuff because when this building opened and we were supposed to be learning how to use all this stuff. As I've told you before, I was off on a vacation at MD Anderson being radiated. But on Monday, Tony won't be here. He has a doctor's appointment. So I got to be able to do all this by myself. So I'm trying to stop Tony from, he's up here doing stuff. No, I got to remember how to, not the math. I know how to do the math. It's how do I get this stuff recorded and all of that stuff. So what program do I open to record and stuff. But Tony's really caught on me lately. So, but at 4 weeks, I'm ready to go. You like to you like to click and enlarge it? Oh, I always just use that one. I guess this is pretty good. Okay. How many of y'all have used graphing tools before? Well, this is a very nice one. Okay. MyLab has some nice graphing tools. Okay. So, did you see what he did? We're going to click right here. Rather than using this area over here, you could use it, but
you've got to find the tool.
Yeah, and here, when you click to enlarge, you notice all the tools are already sitting there. So, okay, it says, click the graph, choose a tool in the palette, and follow the instructions to create your graph. So, you have to know what you're trying to graph. Well, we know what we're graphing. What did we say this equation would be? Starts with an L. A line. Okay. Which of these tools over here look like a line?
One right next to the mouse.
Right. Okay. Right. But if you hover over that one, can you see? Use that bionic eye of yours. It says line tool. If you look real closely, you can even tell that there are 2 ordered pairs there. This is the 2-point line tool, and that's what we need. We have 2 ordered pairs, so we're going to draw a line. We'll click that line tool, And then it says, click the graph to plot the first point on your line. Well, look back at your work. What was that first point that we had? Hold on.
It was x, 0, negative 4.
Okay, so 0, negative 4. Let me go back. Here we are. So we're going to click 0, negative 4. Let's see. There we are. It's the origin. We're going to go left, right, 0. That means we're staying on the y-axis. We go down 4. Notice, do you see where it's showing the ordered pairs changing? Look at the up here at the oh yeah, I changed it. Look right up here in that yellow box. So
technically it's a rectangle. A box is three-dimensional, but I always call it a box.
And then I click, and notice they put that huge blue point there so that you can spot it easily. Now up here the instructions say, click the graph to plot the second point on the line. Well, what was the second point? Look back at your work.
3, 0.
Oh, wait a minute. What was it?
3, 0.
3, 0. Okay, so we go back to the graph. We need 3, 0. We start at the origin. 1, 2, 3. Is that 3, 0? Look in the little yellow box.
Yes.
Do you see 3, 0? And sometimes the increments may be so small it'll be hard to count. So it's a good idea to remember that they say wherever your pointer is, it's showing you up there in that yellow box. So 3, 0, there's the second. So we plotted the 2 points. We click save. And notice something. It transferred it to this graph right here, and then you can say check answer.
So there's 3 parts to every question.
Well, they're going to have you complete a table, and they're going to have you draw the graph for lines. There are some of them, they're not going to give you the numbers they want you to plug in. You have to choose your own numbers. So, but here they're being nice at the beginning. They're telling you the numbers. Look, they're not for number 2. Look at that equation.
Y equals to 5.
Well, do you agree this is going to be a line? You have x's, you have an x, you have a y, you don't have an x squared, you don't have a y cubed, you don't have an absolute value or a square root. This is standard form for a line. So let's write the problem down.
Since we already know what the x is, so we can just put it to 4 times 0 plus 5y equals 20.
I'm going to write the problem down
When
the
you're
way
doing
it's
it at
written.
home, a lot of you can do this without any work or writing, but yep. Our goal is to show our logic here.
They're not using a table. Here they're going through using ordered pair representation. Notice the first number, the x value is 0. So you have 4 times 0, which is
0.
plus 5y, so that says 5y equals 20.
Divide both sides by 5 to make it y equals 4.
So my y value is 4.
I'm
Now,
thinking of something. Years ago, I had a student that kept getting the answers real fast, calling them out, and they were wrong every time. It took me a long time. I felt so stupid when it finally dawned on me.
it didn't
what
dawn
was
on
he
you. You
doing
were telling
wrong?
me, and I told you what was happening.
Once I realized what he was doing was, let's see. When he plugged the 0 in, put your book here.
Well, when he plugged the 0, 4 times 0, he just made it 40. He just replaced the x with a 0, and I was the one, when you were talking about it, I was the one
Where is
that...
he getting those numbers? If we were going to plug a 4 in, it wouldn't become 4 times 1. It was 41, and he was getting all these strange numbers so fast and calling them out. And I would be like, and during class, I never figured out what he was doing, and he didn't make it clear that's how he was getting the numbers. But really, you're multiplying. Like in this one here, plug a 0 in for y. Can y'all sort of do that in your head?
Yes.
Plugging a 0 in for y.
Write it out, your thought process, Tim.
We're plugging in a 0 for y. So we have 4x.
Plus 5 times 0, which is 0.
So just 4x equals 20.
Divide by 4 on both sides, so x equals 5.
So there's my second ordered pair, 5, 0. So here are the ordered pairs we're going to be graphing. 0, 4, or I should say plotting. We're going to plot 0, 4, and 5, 0. And now we click to enlarge the graph. Once again, we know this is a line. And the order in which you plot the points doesn't matter. You can plot 5, 0 first. 5, 0, I'm going to do that. That second point that we found, you go to the right 5 and up 0. And then the second point, 0, 4. Left, right, 0, up 4. Is that the point I want?
No, because it's negative 4.
I don't think so.
Oh, wait, never mind. Sorry. Yeah, that is sorry.
Let's look.
Sorry, I got
Okay, there was. Okay, so we got the 5, 0. Here's the one I'm plotting now, 0, 4. It's a positive 4. Okay, so.
I didn't write down that question, so that's why I got.
Okay, so what did I say? 0, 4.
0, 4.
There it is. Click it. You can't check it from this pop-out screen. You have to say save. And then check answer. Any questions there? Okay. And the next type of figure we're going to be graphing. Well, before we go on, I want to mention something else. Go back to that.
I wanted to mention, some students have asked, how do they print out their homework? If you want to print it on paper and then work it out. This isn't a good one to work out and then use punch in your answer, because you've got to be graphing those. But it's right here under the settings key, a little settings emblem. If you say print, and this is for all the homework, it gives you the choice, either print just this question or print the whole assignment. And it says I can't print it because I have to do the media first. I thought that I'd made that not required at this point. Well, let us jump to it. Well, anyway, okay. So I should have clicked on all the media. But go ahead, Tim.
Okay, the second, I wanted to mention, the point where a graph passes through an axis is called an intercept. That point right here, where my mouse is pointing, can y'all see it? That point where the graph passes through the x-axis is called the x-intercept. I'll write that down in a moment. This point here where the line's passing through the y-axis is called the y-intercept. So I'm going to make a note, because you may see this terminology later on. X-intercept. That's the point where the graph passes through the x-axis. Point where a graph passes through the x-axis. And I'm going to make another observation. Remember what I said earlier. If a point is passing through the x-axis, if it's on the x-axis, what do we know about the y value? If it's on the x-axis, the point can't go up or down, so the y value must be 0, I agree. So make a note, y is equal to 0. And now the y-intercept. y-intercept is the point where the graph passes through the y-axis, y-intercept. I think I'll just say graph intersects. It's fewer letters. It's where the point where graph intersects the y-axis. And if a point is on the y-axis, we said earlier, if a point is on the y-axis, what must be true about the x value? The x value must be 0. So if you hear someone talking about the x-intercept or the y-intercept, it's where the graph is just intersecting the respective axes, either the x-axis or the y-axis. And the second type of figure we're going to graph is quadratics. Now, you don't need to switch it over yet.
Okay.
Mm-hmm. Quadratics. Hey, we've solved quadratic equations. To be a quadratic, what exponent must we have appearing on the x variable? An x square, okay? So I'll make a note that you have x squared in the equation. And now we'll look at number 3. Okay. Going on to number 3. Oh, look at that equation. What do you see? You see an x squared. I'm going to give some terminology first. The graph of a quadratic is called a parabola.
We can't see you, right?
Oh no, thanks for switching. Thanks for telling me, okay? I forgot to switch. The graph of a quadratic is called a parabola. It is a smooth U-shaped figure. A smooth U-shaped figure, it could open up or down. It might open upward. And we're going to do a lot with quadratics later on in the course. Here we're just plotting points. Or it could open downward. Technically it could open left or right, but once we define functions we'll see that those u's that open left and right are not functions. I'm only concerned with quadratics that are functions. And we'll get a little formula to determine this location of the low point, but that's not right now. Now we're just plotting points to get the shape of the U, or determine that U-shaped figure. So looking at number 3, what was it? Y equals x squared minus 7. Oh, I like this. Notice they give you all of the x values, so you can make your table and then then type in all the y values. I like the way they give you all the x values they want you to use. For the equation y equals x squared minus 7, create a table with at least 3 ordered pairs. Well, we're going to be using exactly 3 ordered pairs. And then graph the equation. Let me write this problem down. And we're making ourselves a table of values. I'm just writing the problem down. Okay, so what is that? A -2, a 0, and a +2. Okay. Well, this is actually very nice because of the way they've given us the x values. The equation's already solved for y, so we'll plug in the x values, Simplify that, and that'll give us the y value. Let's start off with -2. We're going to plug in -2 for x. So we have y equals -2 squared minus 7.
So y equals -5.
Let's see.
It equals -3.
Okay. -2 times -2, that's a +4, minus 7 gives me a y value of -3. So there's my first order pair, 0, -3. What does the second row say to do?
0. So it would be for the 0 squared, which is 0. So y equals -7.
So we're plugging in 0 for x, and that'll give us y equals 0 squared is just 0 minus 7. So we have a y value of -7. And what's this third row saying to do?
Replace x with 2, which it would be the same as the first one because -2 squared and 2 squared equals the same thing.
That's right.
So we y equals -7. Or -3.
Okay.
Sorry.
We're going to, that 2 squared will be another +4 minus 7. That gives us the same thing we got for the first order pair. Those U-shaped figures that we're drawing, these parabolas, are symmetric. The left side should be the mirror image of the right side. So we have our our table with 3 ordered pairs. Okay, these are ordered pairs. Once again, to use the graphing tool, you'll need to know what what sort of figure you're going to be drawing. But because of that square there, we know this is a quadratic. So we expect a U-shaped figure. Once we plot these 3 points, we should see a U-shaped figure appear. Let's see, we come over here, and we've got a -3, a -7, and another -3. Check my answer. And then part B, draw the graph. So there. And I'll expand those instructions. Click the graph, choose a tool in the palette, and follow the instructions to create your graph. Okay, which tool are we going to use?
The U one.
Okay, the one that looks like a U. Now, even if this thing winds up being one that opens down, you still use that U-shaped figure. And notice it says 3-point quadratic tool. So we click that tool, and it says plot the first point on your curve. Well, what was the first point that we got? -2, -3. So we're going to plot -2, -3. Notice how as I move my pointer around, you see how the ordered pairs up there are changing. So -2, -3, is that the point I wanted? Yes. So now I click the second point. Up there the instructions say click the second point. What was the second point?
0, -7.
Let's see. I agree. That second order pair is 0, -7. So we go back to our graph. 0, -7. That means left, right, 0, down, 7. And now notice what the instructions say. I click that second point. It says, click the graph to plot the last point of your curve. Notice as you move around, this thing is creating every possible parabola that contains those 2 points. So what was the third point? I need to find that.
-3.
+2, -3. So +2, -3. Is that the point I wanted?
Yes.
Okay, I'll click the 2, -3. I save it. then I'm going to notice it transfers it. Once you save it, as I said earlier, it transfers it to the original grid. Check answer. Any questions there? Okay. I want to do number 7. Oh, look at this. It just says graph the equation. They're not giving you the numbers to plug in. Well, in that event, you get to choose what numbers you plug in. I think you'll agree it's easier to plug in for X than for Y. So let's plug in numbers for X. But make sure they're numbers that are easy to work with. Let me write the problem down. This is number 7. Y equals a negative 2x squared. Okay. Oh, this thing's been working, right? Oh, okay. I wasn't paying attention, but has it been working for a long time? I mean, through the class? Yes. It hasn't been dropping in and going out? Oh,
it has been, I got hurt a bit, like on and off, but...
well, that may just be when I turn my head. Like when I turn over here. If I turn over here, I don't think it's very loud, is it? No, because the microphone's right there. Okay, but notice, let me switch back. Okay. Okay. We see that x squared. There's not an x cube. If it were an x cube, we'd have something called a cubic. We'll see that in a moment. But we see the x squared. That's what tells me it's quadratic. So the graph will be a parabola. It's either going to open up or it can open down. They don't tell you how many points to plot. So let me look. Let's see. Okay, I'm going to click here. I'm going to see if they give an idea of... Okay. Yeah, okay. So it's still a... What I looked at here was I hovered over the little quadratic, the U shape, and do you see what it says? It's still the 3-point quadratic tool. You still need to find 3 points. Now in a few weeks, when we look at these things in more detail, we're going to see a very nice 2-point tool that we'll use that'll take advantage of the symmetry of these U's. But at this point, they still want 3 points. So let's make a table of values. Let's plug in easy numbers, real easy numbers for X. Since we get to choose them, what do y'all think will be real easy numbers to plug in?
0, 5, and 10.
0, 5, and 10. Let's see if the grid goes up to 10. Even if we did plug in, if we plugged in, it goes to the x-axis. Notice the x-axis goes to 10. But if we plug in a 10, we're going to get a y value of negative 200. Can we get a negative 200? Can we go down 200? No, we can't go down 200 units.
0, 2, and 5.
How about 0, 1, and negative 1? That's my advice to you, to make sure that whatever number, the numbers you're generating will fit on the graph. I'm going to use, I think I'll write them in numerical order. Negative 1, 0, and positive 1. Okay. I want to make sure that the y values I get fit on that xy grid. I think even if we had used 5, it would, because if we used a 5, we'd get 25 times negative 2. That's negative 50. Can't go down negative 50 units on that grid. They're only giving you 10 units in each direction. So let's start with negative 1. Plug in negative 1. X equals a negative 1. Then y equals a negative 2 times negative 1 squared.
So the square root negate the negative, so it's negative 2 times 1, which equals to y equals negative
That's correct. Realize, though, you perform, according to the order of operations, you perform exponentiation before multiplication. So that -1 squared, that square gets rid of that negative. -1 times -1 is +1 times -2 gives us a y value of -2. I like plugging in 0 because I can do that in my head. And more importantly, I think y'all can do that in your head. Plug in a 0 for x, what are you going to get for y? 0. That would be a -2 times 0, which is just 0.
And for the 1, because there really won't be a change when you square it, it will be -2 as well.
That's correct. When you plug in that +1, you have y equals -2 times +1 squared. Well, +1 squared is the same thing as -1 squared. So you just have a -2 times 1, which gives you a y value of -2. So let's go, and we don't have to, there's no table for us to punch in those ordered pairs. The ordered pairs we're just using to draw the graph. Notice it's not like that previous problem where you have to punch in those y values. You're just using those that table that you made in order to draw the graph. We click on the 3-point quadratic tool again, and it says to plot the first point. So that's a -1, -2. Is that the point I wanted? Yes. And then what was the second point that we had? 0, 0, the origin. So 0, 0, click it. And now, okay, that last point is 1, -2. So we come over here. We're going to click it. Let's see, 1. -2, is that the point I wanted? Yes. Hey, notice this U-shaped figure is opening downward. Notice now the U shape is opening downward. That's perfectly fine. Save it and check answer. Any questions there? Okay. So we've graphed lines, we've graphed quadratics, those things have x squares in them. Now we're going to graph cubics. Let me write this down.
You can't see it.
Let me switch it over. So graphing cubics. A cubic must contain an x cube. And that has to be the biggest exponent. Can't have an x to the 4th or an x to the 5th. So when you look at an equation that's a cubic, you can spot it because of the presence of that x cube term. And this is number 5. There. So I'm going back to number 5. No, it's number 4. No, it's number 6. Yeah. 1, 2, 3, 7. I put, there it is. I didn't even list this as one of the problems to do. Yeah, I went straight to the absolute values. I skipped over. I always do cubics before absolute values. It just goes so well with this. Quadratics have x squares, cubics have x cubes. Notice something. They're giving you a table to complete, and in this case, they're going to need you to to fill in 4 ordered pairs. To graph a cubic using the cubic tool in MyLab, it requires 4 ordered pairs, and they've given you some pretty easy x values to plug in. Because think about it, if you plugged in an x value of 5, 5 times 5 times 5, wouldn't that give you 125 minus 2? That's 123. I can assure you the grid they're going to give you will not have that many units. So it's like that one that we just finished. The numbers you're plugging in must give you y values that will fit on the grid when it comes time to graph. Let me write this problem down. Number 6. So the equation is y equals x cubed minus 2. And we got our little xy table. So we have to plug in -1 for x. We have to plug in 0 for x. We got to plug in a +1 for x and a +2. And it's that little cube there that says this graph is going to be a cubic. So let's get started. We'll plug in -1 for x. Plugging in -1 for x, we get y equals -1 cubed minus 2. -1 times -1 times -1 gives me -1.
So -1 minus -2 equals to -3. So y
Gives us a y value of -3. Now we'll plug in 0.
Anything times 0, even itself equals 0, so it would just be y equals 0 minus 2, which equals to y equals 0.
That's why I like to plug in 0, okay? Because that term with any term with x is going to become 0. 0 cubed is 0 minus 2. I agree, it's just a -2. Oh, a +1.
1 times itself is just 1, no matter how many times. So it's just 1 minus 2, which equals to y equals -1.
I agree. 1 cubed 1 to any power is still 1. Minus 2 gives me a -1 y value. And the last one?
It's 2 cubed, so it's 2 times 2 times 2, which equals to 4 times 2, which is 8. Minus 2, which equals to 6, so y equals 6.
Okay, so we have 2 cubed minus 2. 2 cubed, I agree. 2 times 2 is 4 times 2 is 8. Minus 2 gives me a y value of 6. I wanted to do each ordered pair in a different color, and so I had to use green. Hopefully I can read that green ink. And now we're ready to draw the graph. Once again, Pearson has a very nice graphing tool for cubics. Okay. So, we better type in the answer of these ordered pairs. Y'all call them out to me.
-3, -2, -1.
Now, let's just stop right there. In that little moment, if you graph these first 3 points, it's going to be a line. Notice, for each 1 unit change in x, the y value is only changing by 1. That looks like a line. But when you get to 2, is this y value going to change just by 1?
No.
It's going to give us
6.
a 6. Imagine plugging in a 10 for x. That would be 1,000 minus 2. So when you're out 10 units on the right side, you're up almost 1,000 units. This is going to be an extremely steep graph on the sides, on the edges. That's what's unique about these cubics. Eventually the edges are going to be extremely steep. As those x values increase in magnitude, the y values, oh, look at that. There. And remember, I warned you that it'll get to a point where it's sort of hard to count units easily. So I'll be looking up here in this yellow box to see where my ordered pair is. But the first thing we have to do, we have to choose the correct tool. It's not a line. We know it's not a quadratic. If you have it right here beside it, what does that say?
4.2 for 2.
Okay, so use 4 points, and it's for cubics. That's what we have. So I'll click that. It says click the first point. The first point was -1. Oh, look, they're changing the scale on the x-axis versus the y-axis. Notice the x-axis is pretty wide, but on the y-axis, notice how small those units are, because those y values can get so big. So it's -1 and -3. Is that -3?
Yes.
Notice in that yellow box there, it says -1, -3. We click the first point. Then the second point is 0. The second point, 0, -2. So that's what we're going to plot now. Left, right, 0, down 2. Is that it? Yeah, notice that yellow box. That's where I'm looking to make sure I have the correct point. And I'll wait. The third order pair is 1, -1. So right 1. And notice when you click right there, it certainly looks like a line. But as soon as we click that fourth point,
Which is 2, 6.
okay, 2, 6, right 2, up 6, right 2, up 6.
Yeah.
Looking in that yellow box, I see that I'm at 2, 6. I click it. I save it. Check answer. Any questions there? Just keeps getting easier and easier, doesn't it?
Okay.
Oh, goodness. The weekend's almost here, y'all. Hang in. I'm so surprised some of y'all are just working ahead and you're still coming to class even though you've already done the homework. I'm just so impressed with y'all. Of course, there's some that have not even clicked on a homework assignment this semester, but we're not going to go into that. Absolute value equations. I think I'll say absolute value graphs. Absolute value graphs. Okay, so absolute value graphs. What do you think is going to have to appear in order for it to be an absolute value? What do you think will have to appear in the equation? The equation has to contain absolute value bars. Now, with an absolute value graph, I'll say equation must contain absolute value bars and absolute value graphs, the kind that we're going to be looking at. They're sort of similar to a parabola, the U-shaped figure, except they're a V-shaped figure. By V, to me a V has a sharp point, okay? There or there. You'll see the difference between a V shape and a U shape. A V shape has a sharp point. The U shape has those smooth turnarounds. So, for an absolute value, that point where the graph changes directions is called the vertex. So the vertex will either be the low point on the graph or the high point on the graph. To determine the x value where the vertex occurs, you have to set the stuff inside the absolute value bars equal to 0. So let's look at, what is it? Number 5. Okay. Here's an equation, y equals x minus 5. Now, in this one, they're giving you a table to complete. The next one they won't, okay? But you have to get that vertex. You have to know where that low point or high point is going to occur. The vertex will occur when that step inside there is equal to 0. What x value would make the step inside there equal 0? X minus 5. What x value would make that step 0 in there? 5. And so we're going to have to plug in a 5, okay? So when they're giving us the values, 5 has to be one of them. But I'm going to go ahead right now and write out that the vertex occurs, because on the next question, they're not going to give you a table. You'll have to choose your own points, and you got to make sure you get that vertex, okay? There are two of these absolute values. Okay, what was it? I didn't write that down. Let me write this. Well, I better write down the observation I was trying to make first. I'll say the vertex occurs when, I need to say it a little fancier rather than just saying the vertex occurs when the stuff inside the absolute value bars is equal to 0. How could I say it? You know what? I'm going to not say it fancy. I'm going to say it I'm going to write it the way I just said it. The vertex occurs when the stuff inside the absolute value bars is equal to 0. And okay, going back to that number 5, let me write the problem down. Y equals the absolute value of x minus 5 and they have a table of values. Let me get started. Okay, so we have, first of all, an x value of -4. So this is saying plug in -4 for x. Plugging in -4 for x. That'll give me y equals absolute value of -4 minus 5. What's -4 minus 5? -9. Now be careful. What's the absolute value of -9? You would be surprised how many people would write -9 here and forget to take the absolute value. What should we have here? The absolute value of -9, I agree, is +9. So there's my first order pair. They're going to make me come over here and punch that number in before it gives me the next x value. Now, where's the sharp point going to occur? The graph is going to be a V. What did you say? When is that stuff inside there equal to 0? What would x have to be to make that stuff inside there equal 0? 5? They're going to have to give us a 5. So let's see, maybe 5 will be the next number. It sure is. There it is. They want us to plug in a 5 for x. So letting x equals 5. Oh, this is easy. Y equals 5 minus 5 is 0. The absolute value of 0 is 0. There's my second order pair. And that's going to be the vertex. That's going to be that sharp point. I'm even going to make a little note of, well, why did y'all tell me? Oh, goodness. I've been going on along. Y'all can't even see what I'm doing. Oh, we used to have a colleague years ago. She's retired. But she saw it all in her head. She'd sit up at the desk. Students would ask questions. And she'd sit there just talking through. Just talking through. And it was impressive, but the students were trying to write down what she was saying, and it wasn't a very successful pedagogy, you might say. But anyway, I plugged in 5 for x. 5 minus 5 was 0. The absolute value of 0 is 0. Let's go back and plug in that 0, or type in that 0. Okay. Oh, they have another one they want us to plug in. I think they're only going to want, I think we're only going to have to do 3 points. So plugging in 14. X equals 14. We get y equals the absolute value of 14 minus 5. That's, oh, wait a minute, thank you. Oh, goodness. Okay. 14 minus 5, that's a 9. Thank you for pointing out that you couldn't see what I was writing. And the absolute value of 9 is 9. There. So we plugged in the 14. 14 minus 5 was 9, and the absolute value of 9 was 9. So let me go back. What am I going to type here? They really didn't have to give you something that would give you the same y values. It's just they could have given you a 10. Okay? But here they gave you points that were symmetric. Let's see. Now we're going to draw the graph. Click to enlarge. Okay, there's the absolute value tool. Notice it looks like a V. So you have to click the tool that you want. This is the only tool that we're going to have where the order in which you label the points matters. Look at this. Click the graph to plot the vertex. They want the vertex first. Let's see, the vertex. That's the middle point. So if you plot that -4, 9 first, then you're going to get your graphs wrong. You're not plotting the points just in the order in which they gave you. You have to plot the vertex first. That's why I was asking you, when is that stuff inside there equal to 0? Because that's where the vertex occurs. And I even labeled that middle point vertex. So we come over here. The first thing we plot is 5. Oh, look at those little bitty. Is that it? Is that 5, 0?
Yes.
Yes. So I click it, and then look what it says. Now plot another point. Only one point. Notice, as I move it's taking advantage of the symmetry of those V-shaped figures. This is very similar to that more advanced quadratic tool we'll get in a couple of weeks. But right now, notice, it's drawing out every possible absolute value with a vertex at 5, 0. So what do y'all want to use? It's up to you which point we use. We can either use -4, 9 or 14, 9.
There's no really a 14, -4, 9.
Yeah, there isn't. Is there not even, let's see. Oh, there is a -14, but I think I'm in a positive 14. but I'm going to use that negative 4, 9. Okay, negative 4, oh, I moved. Is that the point I needed? Negative 4, 9. Do you see there in the yellow box? Yes. And notice, when you click it, it has the nice V shape, not a U shape, the V shape. We save it and check our answer. Any questions there? Okay, number 8. It's another absolute value.
So this one we don't have any.
They don't give us any points. You have to choose them yourself. Okay, let me write the problem down. This is number 8. We want to graph y equals the absolute value of x plus 4. We only need 2 points to graph an absolute value.
Negative 1 and 1 would be
Okay, negative 1 is a good one, but the first point I'm going to find is the vertex. What x value will make that thing inside there equal to 0? My first thing, where is the vertex? For an absolute value expression, for an absolute value graph, the vertex occurs when the stuff inside the absolute value bars is equal to 0. So, when does x plus 4 equal 0? When x is negative 4. So, when x is negative 4, there's the vertex. Plugging in negative 4 for x, I don't think we need to show anything. We know what that's going to be. What are we going to have inside there when we plug in negative 4? Starts with the z. 0, the absolute value of 0 is 0, so there's our first point. The absolute value tool is the only graphing tool that we've seen today where the order in which you plot the points makes a difference. You have to plot the vertex first, and then you can choose another number to get a secondary point. You only need 2 points, the vertex and one other point. Remember how that symmetry works. And we could use 1 or negative 1. I think I'm going to use an x value of 0.
Yeah, so that it could be y equals 4.
Okay, 0 plus 4 is 4. The absolute value of 4 is 4. So to graph this absolute value expression, I'm not telling you what numbers to plug in. You have to know where is the vertex equal to 0. Where's the inside stuff equal to 0? That's the vertex. That's what I found first. I found the vertex. And then just any other secondary point that'll fit on the grid that they give you. So, no table to enter. We click another V. It's an absolute value. And once again, they want you to plot the vertex first. That's negative 4, 0. Click it. And then just moving around your mouse, you're looking at every absolute value graph you could possibly have with a vertex at negative 4, 0. So the secondary point that we got, what was the second point we got?
0, 4.
0, 4. So we come over here, left, right, 0, up, 4, 0. Look at that yellow box. Do y'all see it's showing 0, 4? So I know I'm at the right spot. Save it, transfer it back to the original grid, check answer. Any questions there? We have graphing tools for lines, quadratics, cubics and absolute value expressions. Anything that doesn't have a graphing tool can be handled using multiple choice. Graphs of square root expressions. Graphs of square root expressions. We know an absolute value equation has to have those absolute value bars appearing. A quadratic has to have an x squared appearing. A cubic has to have an exponent of 3. What do you think the graph of a square root expression has to have? It has to have a square root. The equation, that seems too obvious. I'm not going to write that down. The equation must contain a square root. Let's see, this is number. Oh, we're going back to number 4. And hold on. Y equals the square root of x minus 4. This is number 4. Y equals the square root of x minus 4. Just plot enough numbers to, this is the one thing where I'm going to graph it on paper, and then I'll just look and see what graph looks like the one that I got. We're going to have to choose some x values to plug in. For the graph of a square root expression, I guess I should have written a note up here. You don't want imaginary y values. With that in mind, can we use 0 for x?
No, we can't.
No, because if you use a 0 for x, if you try to use a 0 for x, you get y equals the square root of negative 4.
Which will turn into y equals 2i.
That is an imaginary number. You can't label imaginary numbers on number lines. That's why they're called imaginary. So when you're graphing a square root expression, make sure you do not get imaginary y values. I'll say avoid imaginary y values. When I'm graphing a square root expression, I ask myself the same thing I ask myself when I'm graphing an absolute value expression. Where does the stuff inside that square root, with an absolute value, I ask myself, when is the stuff inside the absolute value equal to 0? With a square root, I ask myself, when is the stuff under the square root equal to 0? When is x minus 4 equal to 0?
X will equal 4.
When x is equal to 4. So
the square root of 0, which is just 0, so that's why we take 0.
now, one side of 4 is going to create imaginary numbers. The other side of 4 is going to give us numbers, real numbers that we can plot. So we know 4 is going to be a starting point. But one side of 4 is going to give us imaginary numbers. I think we already know based on 0. We can plug in a 4 for x, and that's going to give us a y value of 0. Okay. Suppose we tried to plug in a 3. 3 minus 4.
That's negative 1, which we can't do.
That's-
So it calls an imaginary.
That's imaginary. You're right. Well, what about, so we can't go to the left of 4. That means we should be able to go to the right of 4, something like a 5. If we plug in 5 for x, what are we going to get?
The square root of 1 will just equal 1.
That's right. And we can plug in 6. If we plug in 6, 6 minus 4 is 2. The square root of, 6 minus 4 is 2. The square root of 2, oh, that's not a perfect square, but it's about a 1.4. But I'm not going to bother trying to plot that point. Okay, it's about a 1.4. This is a multiple choice problem. I bet that we can look at the 4 options and see what the graph looks like based on the 2 points that we have. Remember, these points have to be, they're solutions to the equation, so they have to be on the graph. Which graph has 4, 0 and 5, 1? Let's look. Maybe we can pick it out right here at this step. I think this is the first time we've had I know it's the first time we've had a multiple choice absolute value, a multiple choice graphing problem. I'm going to blow up each one of these pictures, and we'll see if we can tell which one is correct. Here's the first one. This one. Does that look like it has 4, 0? 1, 2, 3, 4, 0? Certainly not. Okay. Does this look like it would have 4, 0 and 5, 1? No, that's what, if they're incrementing in units of 2, that would be a 2, 0, not a 4, 0. Look at this. Oh, there. Can y'all see that? They're incrementing in units of 2, so there's 2, 4, up 0, and then 5, that'd be right there in between, up 1. So I think it's going to be graph C. Now over here, let's see. It certainly doesn't have, as a matter of fact, it's plotting x values. It's using 0 as an x value, right there intersecting the y-axis. The only one it could be, the only one that could contain those 2 points we found was C. And I'm going to draw this graph manually because I want to make a point of this. There's something I want to point out. Okay, so I'm going to draw my XY. Oh, that's that's a different class. Go right away. Okay, and so I'm going to draw my XY grid. Okay, so we said we had 4, 0, 1, 2, 3, 4, and then 5, 1. The graph can't go back that way because if we went that way, we'd have negative y values. Imaginary y values. So it starts here and it goes up, but it's a very gradual increase. It has a starting point for the thing under the square root equals 0, then 5, 1, it'll be 6, 1.4, so it's going up, but it's a gradual increase. Suppose I'd plugged in 104. 104 minus 4 is 100. The square root of 100 is 10. I said the graph was increasing very slowly. So when we're way out here, 104, we'd be off this green map, wouldn't we? We'd only be up 10 units. So way out here, we're not going, when we're way far out over here, it's still not up very high. It's increasing very gradually. For square root graphs, be careful. Don't plug in x values that will generate imaginary numbers. Do what we do with absolute values. When will the stuff underneath there be 0? And use that as the starting point to get, 2 or 3 points. Any questions there? There are two important formulas here in this section. So, given two ordered pairs, and to denote these two ordered pairs, I'm going to label x subscript 1, comma, y subscript 1. I can read that as x sub 1, y sub 1. Out of laziness, I usually just say x1, y1, and x2, y2. We have two formulas now. The distance from one point to the other is given by d equals the square root of, you subtract the x coordinates, so I'm going to go x sub 2 minus x sub 1 quantity squared plus subtract the y coordinates. The order in which you subtract them doesn't matter, but I always start with the second order pair. That's the standard statement for the formula. Y sub 2 minus y sub 1 squared. That's all under the square root symbol. And I think we all know what the distance, of what we mean by distance. Really, it's the shortest distance. You put the measuring tape at one spot and you stretch it to the other spot, okay? That's what we mean by distance. Now, the midpoint of the segment connecting the 2 points is given by, it's an ordered pair. You average the x coordinates and average the y coordinates. You're trying to find out what number is midway between the x values and what number on the x-axis, and what number is midway between the y values on the y-axis. To find that, you're averaging. You average the x coordinates, add them up, divide by 2, average the y coordinates, add them up, divide by 2. So, graphically, let's say here's the point x1, y1, and right there's the point x2, y2. The length of that line segment is given by the distance formula. That distance, that length, if you took a measuring tape and started here and stretched it over there, that would be the distance. And the midpoint, it's the point that divides the segment in half. So maybe right out there, does that look like that? Does the distance from that black point to the first point look the same as the distance from the black point to the second point? I think so. There's the midpoint. So that's what it means graphically. The distance is the length of the line segment connecting them. The midpoint divides the segment in half by length. And there's some problems where they want you to find the distance and midpoint. They're just having you plug the things in. Number 9. Oh, better write this problem down. This is number 9. For the coordinates P, negative 26, so we have the point P. They're labeling the points with letters. That's a common practice. I generally don't do that, but this textbook author is. And then we have another point that she's naming Q, negative 13, comma, negative 3. So point P is at the ordered pair negative 20, negative 6. Point Q is at the ordered pair negative 13, negative 3. They want us to find the distance from P to Q. Notice they're being fancy there. Notice that little D, comma, P, D parenthesis, P, comma, Q, close parenthesis. That's just their way of saying the distance from P to Q. And then they want us to find the midpoint. So we're finding the distance from the 2 points and the midpoint. Recall the distance formula. The distance formula is equal to, if you don't recall it, look back where I stated it a moment ago, okay? Okay, hold on. Recall where I stated it a moment ago. You subtract the x coordinates, quantity squared, plus subtract the y coordinates, quantity squared. And what I do, yes, oh, thank you, there. What I like to do, I like to actually identify x1, y1, x2, y2. The distance from P to Q is the same as the distance from Q to P. So it doesn't matter which one you consider x1, y1 or x2, y2. The first one I write down, generally that's what I think of as x1, y1. The second point I write down, that's x2, y2. So okay.
So the first one would be negative 13.
Okay, x2 is negative 13. So we have a negative 13 minus.
Actually, it would be plus 26.
I'll change it to plus in a moment. Right now, I'm just going to write the negative 20. So negative 13 minus a negative 20 minus a negative, that becomes a plus. What about here?
Negative 3.
Okay, y2 is negative 3. What am I going to write here?
Negative 6, but
okay.
2 is positive 6.
And that minus and negative will become a plus. Any questions on our logic so far? Okay, negative 13 plus 20, that's 7.
So the square root of 7 is 49.
No, not the square root. 7 squared is 49. I know what you mean, though. Okay, what about this one? Negative 3 plus 6
3.
becomes a positive 3.
And that would turn into plus 9.
So 49 plus 9 gives me the square root of 58. And people that, some teachers dislike my math lab because they can't control the numbers. They can get all sorts of messy numbers in it. Well, I say they're very nice. I think that my math lab, despite it all, they're generating these numbers randomly, but there's an algorithm they use. So the numbers aren't that bad. The square root of 58, well, 58 is what, a 2 times 29? There are no perfect square factors. You're just left with the square root of 58 as the distance. So we come over here, we click. Okay, we've typed square roots before. We go, notice, and we hover down here on the toolbar, And remember, you have to click in the box before the toolbar appears. The square root of what's underneath there, 58. Any questions there? Now the midpoint formula. They want us to find the midpoint. We average the x coordinates. We average the y coordinates. Remember I said that the midpoint is given by averaging the x coordinates and averaging the y coordinates. That's what we're doing here. Add them up, divide by 2, add them up, divide by 2. So, right there, midpoint, you're adding the x coordinates, dividing by 2, adding the y coordinates, divide by 2.
So the first one is negative 20 plus negative 13, or just negative 20 minus 13, which will equal 33 over 2.
Okay, let's see. Oh, I didn't need this little dot there. I didn't just lay my pen down. Now, wait a minute. What were you saying? I wasn't paying attention.
The first one would be negative 20 plus negative 13.
Okay, so we're adding the x coordinates. I agree. Negative 20 plus a negative 13. Negative 20 plus negative 13 gives me what?
Negative 33 over 2.
So negative 33 over 2. Negative 33 halves is midway between negative 20 and negative 13 on the x-axis. What would that be? Negative 16 and a half? Yeah, that sounds about right. Negative 16 and a half would be between negative 20 and negative 13. Now, what number is midway between negative 6 and negative 3 on the y-axis?
Negative 9 over 2 would be negative 4.5.
Okay, I'm going to write it out. y1 is negative 6. y2 is negative 3. Negative 6 plus negative 3, I agree with that. Negative 9 over 2. So, negative 4.5, yeah, that'd be midway between negative 6 and negative 3 on the y-axis. And there.
You just write it like that, or do we have to?
Now, this is the form. This is if it were 66 over 4, they'd want you to cancel a common factor of 2. But
it's 0.5 not to do it.
Generally, they do not want decimals. I bet you if you wrote negative 4.5 and negative 16.5, I bet you they'd count it wrong. Leave it as an fraction in reduced form.
Let's try it with the decimals to see.
Type an ordered pair using integers or fractions. So they're saying...
I mean, it wouldn't be bad to see, like, if they will just in case. No?
Okay, I'm going to see negative 16.5, comma, negative 4.5. Who knows? There might be a nice little programmer that went in on a spare time and was like, oh, we should take decimals. Let's see. He didn't change the instructions because he didn't want his supervisor to know what he was doing. But he was going to cut y'all some slack and let you enter decimals. Let's see.
Yes,
Yep. So that, I wasn't expecting that. Okay.
That's why you should.
Oh. Any questions there? Some of y'all are looking dazed or have a glazed look on your face. There's another distance midpoint formula. And starting at number 11, I think it's back to old stuff. So there's only 10 problems in new material here. Starting at number 11, it's old material to make sure you don't forget the stuff. Let's do this number 10 and then we'll call it quits. Number 10, let me see. Point P is 23, comma, negative 9, and point Q is 30, -6. So, same instructions, find the distance and the midpoint. So, as I said, I like to label the ordered pairs x1, y1, x2, y2, distance, subtract the x coordinates squared plus subtract the y coordinates squared. So, y'all call out what's going to go here. 30, I agree. Here, 23, I agree. 30 minus 23, here. -6, here. Okay. Well, 30 minus 23, we know that that's 7. Isn't that what we got a moment ago? 30 minus 23 is 7. 7 squared is? I better write it out since y'all are so quiet. So that's 49 plus, what's -6 minus -3? Well, this is a bizarre coincidence, isn't it? -6 minus -9, that's -6 plus 9. That's a 3 squared. Aren't we getting the same thing? Isn't that what, that's just a coincidence. That is just a coincidence. The points aren't the same. It's not exactly the same problem, is it? No? They're clearly different ordered pairs. Just so happens, I guess that programmer that let y'all enter in decimals decided, oh, I'll make everything the square root of 58 to be nice to the students. I'm sure that's not what happened. And then the midpoint, almost finished. Remember, we average the x coordinates. We average the y coordinates. Add them up, divide by 2. So adding the x values, 23 plus 30 here. Adding the y values here, -9 plus here.
-6.
So that's what, a
53 divided by 2, and the other one.
Oh no, 53.
The other one would be 15 divided by 2.
-15 over 2. And this time we're going to do what the instructions say and type it in as fractions. But the other one, even though it said it's the square root of 58, and that's the same distance that that number 9 was. Oh, I know. The points are different, but, and now, we typed in a decimal a moment ago, but, and it worked. I don't really care for decimals. If that's a denominator of 3, then it's not going to terminate. So, uh-oh, but I typed wrong.
You typed in 52 instead of 53.
Oh, I wrote 52, did it? Thank you.
Thanks.
Let me start this.
52 and
53 over
Not
2.
5,253.
Go back and let me show them. Let me show them. Corrected. That was 53. 23 plus 30 is 53 over 2. Oh, goodness.
Here's
Well.
a funny picture.
Any questions?
Here's a funny
Okay,
picture.
hold on. I'm going to...
All our life, the two of us had to share as children, you know.
Where
We
did you
didn't
get
get two little horses. We got one to share, and this was a good day, obviously. This one doesn't look so good. I don't know. It's in the mess in the office, and I
Tony,
just
you
thought
look
I don't ever
No, it's
recall
not
seeing
me.
them.
Oh, my God.
I can clearly tell that's me.
And that's me. You always got to go first because you were bigger.
Yeah,
Was I
I
stoned?
it looks good or something. Wow.
And I'm still recording. I'm turning off this recording.
Still, I just thought
Wow.
that was in my office, and I'm not sure.
No, it's still going. It's still going. You just
I
paused the
know. I
screen.
messed up.